Hey guys, I just wanted to make a video here going over the free fall practice problems, those 3 problems for homework, in case you're struggling with them and don't know how to do them, don't know how to use the equations properly and all of that. So I wanted to give you a few examples here. So let's look at the first one here. It says the Steamboat Geyser in Yellowstone National Park in Wyoming is capable of shooting hot water up from the ground with a speed of 48 meters per second. How high can this geyser shoot? So we've got this little geyser here. And so it shoots the water up, and we want to know how high that can get right there. So we want to know that distance. So we are looking for our displacement there. Let's write down the things that we know here. They said it can shoot the water up at 48 meters per second. So our initial velocity is 48 meters per second. This is a free fall problem, so we already know the acceleration. The acceleration, or g we could just call it, and I'll just call it that from now on in these problems, is negative 10 meters per second squared. That negative is really important to solving these problems. Notice this is positive 48, it shot it up, and this is negative 10. It's wanting to go down if it can, the water, as soon as it gets up there. We need to know at least 3 things to solve these problems. We got 2. We're looking for x, right? So what is the third thing? A lot of people miss this, but remember this always. Whenever you're talking about the peak of something, then the final velocity there at the peak is 0 meters per second for an infinitely small moment in time there. So we know those 3 things, and we are looking for the displacement, the delta x there. So now that we see the 3 things that we are given and the 4th thing that they are asking for, we need to find the equation that mentions all 4 of those at once. Or in my mind, I say the one that doesn't talk about time at all. They didn't give us time, they didn't ask for time. And that is what we call the 5th one. So the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. So now let's start to plug in some of our numbers here. So we know the final velocity is 0, and that will get squared, but 0 squared is just 0. So I'm just going to write 0 is equal to 48 is our initial velocity squared plus 2 times negative 10 times our displacement here. So that is what we are looking for. So we've got to square our 48 and move it to the other side. I'm just going to keep that as 48 squared right now. So, and I'm going to subtract it over to the other side. So negative 48 squared, I'll move that over there, is equal to 2 times negative 10 times the displacement there. So now let's solve for displacement. It's going to be, I'm going to divide each side by these 2 things now. So negative 48 squared divided by 2 times negative 10. I'll divide the 2 down there and the negative 10. And if we work all of that out there, I believe it comes out to be about 115. Let me check here on my calculator. Yes, 115. So that is how high it will go. By the way, this negative cancels with that negative right there. So we'll go 115 meters high. All right, let's try the next one here. So the next one, if I pull it up here, says a baby blue jay sits in a tall tree waiting for its dinner. As the mother lands, she drops the worm and it falls for 1.5 seconds. So how high is the nest? So the poor little worm here falls, and it falls, they told us, for 1.5 seconds there. So that's clear that that's one bit of information. So we have the time there, and remember, this is a free fall problem. It is falling, so we already know that the acceleration is negative 10 meters per second squared. We know that. And then also, we know one more thing, and this is what a lot of people miss. If you just drop the worm, then it began at rest. So the initial velocity will be 0 meters per second. And then they say, how high up is it? So again, they want to know the distance that it moves down. So they want to know the displacement. What is that? So now we need to find an equation that mentions all four of these guys at once. Or I think the one that doesn't talk about or ask for final velocity. And that's what we call the third one. So the displacement is equal to the initial velocity times time plus 1/2 times acceleration times time squared. Now there is no initial velocity, so that whole term right there just drops out. And so we're left with this simplified equation. The displacement is 1/2 times the acceleration times time squared. So this time, you know what? I'm gonna go ahead and rearrange it first, then plug in numbers. So I'm gonna multiply each side by 2. That will give me 2 times displacement is acceleration times time squared. I'm going to divide each side by acceleration. That will give me 2 times displacement divided by acceleration, gives me t squared. And then I'm going to take the square root of each side. So that will give me time is equal to the square root of 2 times the displacement over the acceleration, which I know is g. So now let me start to plug in some numbers in this case here. So we get the square root 2 times the displacement, which is, we're looking for the displacement here. So let me scratch all of this off. This comes in the next one, actually, my bad. We're looking for the displacement, so we simply plug it in right here. So 1/2 times the acceleration, which is -10, times the time, which is 1.5 seconds squared. And if you do that, 1.5 squared times -10 times 1/2, that works out to be roughly -11.3 meters is the displacement. So that's how far it moved down. So the answer might be put in as like, oh, it's 11.3 meters high. Like, I'm not going to get you on that positive, negative on the test there. So this bit that I got into right here, that is what we'll do on the next one. We will look for the time it takes to hit the ground there. So let's do the last one with the giraffe. And so it says the giraffe drops a twig and they're 6 meters tall. And so here's our little giraffe. So here it is, 6 meters to the ground here. So how much time will that take? So let's write down everything that we know. We know our displacement. It's going to move from here down to the ground. So this is a small thing that causes some error later. The displacement is -6 meters. It dropped it from rest. So just like the previous problem, the initial velocity is 0 meters per second. And then the other thing that we know, since it's a free fall problem, is that the acceleration is that of gravity, so it's -10 meters per second squared, and they want to know what time does this take to fall. So now we're using the third one again. So the displacement is equal to the initial velocity times time plus 1/2 times acceleration times time squared. The initial velocity, again, in this problem is 0, so that drops out. Now, this is the time where we're going to solve for time. And so, like I started to do on the other one, I'm going to multiply each side by 2. So I get 2 times the displacement is the acceleration times time squared. I'll divide each side by acceleration so that I get this equation. And then I'll take the square root of each side. So I get 2 times the displacement over the acceleration, which is g, will be the time to fall there. So now let me plug in. And here is a small mistake that causes some people a big problem. The displacement, remember, is -6 meters. We move down 6 meters. And the acceleration due to gravity is also -10. If you only put one of these negatives in, lots of times people forget this one. Then they're like, what, I got a negative under the radical, how do I do this? But if you put both negatives in, you won't have that problem. Or if you make a double mistake, you forget that negative and that negative, you're actually okay because you're back to being positive again. So 2 times 6, which is 12, divided by 10, so 1.2, square root of 1.2, and you get about 1.1 seconds is the time to fall.